welcome back. 6.3. We are going to talk about some special lines, parallel and perpendicular lines, and writing the equations with those. First thing we need to talk about are parallel lines are two or more lines in the same plane that never intersect. So let's see what we're talking about here. We have 2x minus 5. So I'm going to start at minus 5. 1, 2, 3, 4, 5. That's my y-intercept. My slope is 2 over 1, so up 2 over 1. Up 2 over 1, up 2 over 1. So if I can draw a line, not so bad. 2x plus 4, 1, 2, 3, 4. 1, 2 over 1, 1, 2 over 1. If I draw this line. Alright, those will pretty much do. Now if you take a look at this, these two are never going to intersect. And why are they never going to intersect? Well, every time I was on here, I went up 2 over 1. Well, at the same exact place, I went up 2 over 1. That's the same rate of change going up the same all the time. Because I'm going up the same and over the same on both lines, my rate of changes, 2, will always cause this never to intersect. All right? So here's a key point. Two lines are parallel if and only if their slopes are the same. That's the key thing here. Two lines are parallel if and only if their slopes are the same. So you can tell right away, if you look at two lines, if I go to my slope for this is 2, my slope for this is 2. I didn't have to graph it. I know because I know the slopes are the same, therefore, bam, they're parallel lines. All right? All right, so now it says write an equation of the line that passes through the point 4, 7. Remember, that's an x and that's a y, and is parallel to the line y equals 5x minus 3. Well, any line parallel to this line is going to have the same slope. So what's the slope of this line? The slope of this line is 5. So our slope for the equation is 5, and if you recall, y equals mx plus b, y equals mx plus b. All right? I'm going to start that out, plug in what I have. 7 equals 5 times 4 plus b. Need to find my intercept. 7 equals 20 plus b. Subtract 20 from both sides. And we find that our b is going to be negative 13. I have a b, I have an m. So y equals 5x minus 13. That is the equation of the line parallel to that equation through that point. Same slope, same slope. All right? Now, the nice thing about parallels, if we have parallel, we also have perpendicular. These two kind of are hand in hand. Perpendicular is not that they just intersect. They have to intersect to form a right angle, all right? All horizontal and vertical lines are perpendicular. Think about it this way. Horizontal, somewhat perpendicular. This angle here is a right angle, just like our x-axis and our y-axis. Those are perpendicular. So let's graph these two. Start at 5, 1, 2, 3, 4, 5. And I'm going to go down to 1, 2 over 1. Down 2 over 1. Try and graph that the best I can. Not bad, Sullivan. Start at negative 2. Go up 1 over 2. Up 1 over 2. And if you can see, they indeed form a right angle. Now, we know it's all about slope. So if you look at this, what's true about negative 2 and 1/2? Well, let's take a look here. These two lines are perpendicular only if and only if they are negative reciprocals. Negative reciprocals, all right? Reciprocal, inverse, when you have a fraction and you flip it. So I have a fraction, 1/2, and I flip it, and it becomes 2 over 1. That's the reciprocal. Now, do I ever write 2 over 1? No, it's just 2, right? And the negative part means if it was positive, now it's going to be negative. So, if I had negative 4, that's the same thing as negative 4 over 1. The negative reciprocal is going to be flip it, 1 over 4, and it was negative, now it's positive. All right? So anytime we have that situation where you can look and you can see that, you know those two lines are going to be perpendicular. So let's try one here. Write an equation of a line that passes through x is 6, y is negative 1, and is perpendicular to y equals 3x plus 2. Well, let's see. Our slope right now is 3. We need to flip it. So that's 1 over 3. And it was positive, so now it's going to be negative. So now y equals mx plus b. Y equals mx plus b. All right. Negative 1 is y. My slope is negative 1/3. My x is 6. And I don't know my b. See, this is all the same stuff we've been doing for the whole chapter now. So negative 1 equals negative 1/3 times 6 is negative 2. Add 2 to both sides. And I get 1 equals b. So my equation is y equals negative 1/3 x plus 1. And if I look, I have negative reciprocals. All right? Now it says, determine which of the equation following lines, if any, are parallel or perpendicular. So remember, we have to find our slopes and then compare them. That's all that really matters is the slope. All right? So for A, our slope, well, that's easy. mx plus b, so our slope here is negative 2. Is this in slope-intercept form? No. So I need to add x to both sides. So now I have 2y equals x plus 3. Divide by 2, and I'm going to get y equals 1 divided by 2 is 1/2 x plus 3/2. This part doesn't matter. What's the slope? 1/2. So my slope for B is 1/2. All right, we got 1/2, we got negative 2. And let's do the third one, so I need to subtract 2x, because I have to get it y equals mx plus b. So y equals negative 2x plus 1. So the slope here is negative 2. All right, so let's do the obvious. Whenever the slopes are the same, they're parallel. These two are not the same, these two are. So A is parallel to B. That's shorthand. You know, you can just write A and B are parallel, but when you have two lines like that, that's shorthand, mathematical notation. All right? Now let's take a look at this. What's the reciprocal of 1/2? 1/2 is 2 over 1, which is just 2. It was positive, so the negative reciprocal would be negative 2. Well, both of these are negative 2. So B, excuse me here, that's not B. A is parallel to C. But B is perpendicular. The notation for that is an upside down T to A and C. All right, so we have A is parallel to C. A and C have the same slope. And B has a negative reciprocal slope with A and C, so it's perpendicular. Okay? All right, I want you to pause the video and try this one. All right, let's take a look. So we know we need y equals mx plus b. Let's see all the information I can find. Perpendicular. Oh, this needs to be in slope-intercept form, so I'm going to subtract 2x. So now I have 4y equals negative 2x plus 12. Divide by 4. Y equals negative 2 divided by 4 is negative 1/2 x plus 12 divided by 4 is 3. All right, so my slope is negative 1/2. So if I want it to be perpendicular, the slope over here has to be a negative reciprocal. Flip it. That's 2 over 1. Was negative is positive, so the slope is going to be 2. So plug in what I know. I know my y is negative 1. My slope is 2. My x is 8. And I don't know my b. So negative 1 equals 16 plus b. I'm going to subtract 16. Negative 17 equals b. So y equals 2x minus 17. All right. Found a video of Mr. Brust last year actually teaching his kids about perpendicular lines. So you can take a second and enjoy this video of Mr. Brust. Good luck on the master check.
You're so fine. Could you be a curve or could you be a straight line? Your touch intersecting, feeling so familiar. I think it could be linear. They say, be afraid, but you are like my angel. We make a right angle, different degrees. You and I make 90 in the Cartesian plane. The same 2 dimensions. You cross through my line. and I'm ready to go from the left to the right. Grab me, this is my infection, the point of intersection. Take me, lead me like a squadron, take me through the quadrants. Girl, you're not parallel, your touch so closer. We're perpendicular, Our slopes are in sync, they are so atypical, the opposite reciprocal. Prove that we meet, don't forget your logic, in the Cartesian plane. The same two dimensions, you cross through my line, and I'm ready to go from the left to the right. Grab me, this is my infection, the point of intersection. Take me, lead me like a squadron, take me through the quadrants. Girl, you're not parallel, your touch so closer. We're perpendicular,